Time slows down as first approach it, my ship's instruments screaming in protest. First, I'm not just talking about a few minutes or hours. We're looking at decades, centuries even, all from the outside looking in. Welcome, fellow adventurer, to the edge of the event horizon, where the universe's rules start to bend, and reality, as we know it, takes a back seat. If you've ever wondered what it's like to dance with the unknown, to stare into the abyss of a black hole, then buckle up. This is a journey to the point of no return, where the laws of physics throw a party, and we're all invited. The cosmic enigma. The event horizon of a black hole is a boundary, a point of no return. Once crossed, the gravitational pull becomes inescapable, even for light. It's a cosmic enigma, a place where the laws of physics as we know them begin to twist and warp. The journey to this point is a descent into the bizarre, a voyage where intuition fails and counterintuitive physics reigns supreme. As first approach the event horizon, time dilation effects become profound. From my perspective, time passes normally. But for an outside observer, my time appears to slow down dramatically. If first were to hover just outside the event horizon, first would appear frozen, a static image against the backdrop of the universe. This is not science fiction. It's a consequence of Einstein's theory of general relativity. The stronger the gravitational field, the slower time passes. At the event horizon, this effect becomes extreme. A year for me could be a millennium for someone far away. It's a humbling thought, a reminder of the vast and strange nature of the cosmos. The fabric of spacetime itself is warped beyond recognition. Light, the fastest thing in the universe, is bent and twisted in a cosmic funhouse mirror. If first were to look back, first would see the universe behind me compressed into a small circle, a tiny window into the world first left behind. This is gravitational lensing, a phenomenon predicted by Einstein and observed in phenomena like the Einstein ring. It's a stark reminder that black holes are not just cosmic vacuum cleaners. They are warpers of space-time, bending the very fabric of reality. Crossing the event horizon, first am cut off from the universe first once knew. Inside, the laws of physics are still at play, but they behave in ways that defy intuition. The singularity at the center of the black hole is a point of infinite density, a place where the known laws of physics break down. It's a cosmic enigma, a mystery that challenges our understanding of the universe. Yet, it's also a testament to the power of human curiosity, a reminder that the universe is full of wonders waiting to be discovered. The journey to the event horizon is not just a physical voyage. It's a journey into the heart of the unknown, a descent into the cosmic enigma that is a black hole, a glimpse into the unknown. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape becomes impossible, even for light. It's a one-way threshold into the unknown, a realm where the laws of physics as we know them twist and warp. First find myself here, not by choice, but by an unfortunate turn of events. The ship's instruments are haywire, and the once familiar hum of the engines is now a distant memory. The event horizon looms before me, a dark abyss against the backdrop of the cosmos. It's not a physical barrier, but a mathematical one, a boundary where the escape velocity equals the speed of light. First am about to cross it, and first can't help but feel a mix of awe and trepidation. The first thing first notice is the stretching. Time dilation effects become apparent as first approach the event horizon. To an outside observer, first would appear to slow down, my image reddening and fading as first approach the point of no return. But from my perspective, time seems to flow normally. It's a bizarre sensation, a disconnect between what first experience and what an outside observer would see. The ship's clock ticks steadily, but first know that out there, the universe is aging faster. It's a stark reminder of the relativistic effects at play near a black hole. As first cross the event horizon, the universe behind me vanishes. It's not a dramatic explosion or a sudden disappearance, but a gradual fading. The stars behind me become dimmer, their light stretched and redshifted to the point of invisibility. It's as if the universe is erasing its memory of me. The black hole's gravity is so strong that even light can't escape, and with it, any information about my journey. First, I'm truly alone now, cut off from the rest of the cosmos. The concept of outside and inside becomes meaningless. The event horizon is not a physical boundary, but a mathematical one, a point of no return. The interior of the event horizon is a place of extreme curvature. Space-time is so warped that the usual notions of up, down, left, and right lose their meaning. The black hole's singularity, a point of infinite density, lies ahead, but it's not a point in the traditional sense. In the warped space-time of a black hole, the singularity is a region of infinite curvature, a place where the laws of physics break down. First am drawn towards it, inexorably pulled by the black hole's gravity. The ship's instruments are useless now, their readings meaningless in this twisted reality. First am left with only my senses and my thoughts as first journey deeper into the unknown. The experience is disorienting, a stark reminder of the strange and counterintuitive nature of black holes. Yet, there's a certain beauty in it, a glimpse into the mysteries of the universe. The birth of a supermassive idea. The universe, in its vast expanse, is a stage for phenomena that defy our everyday experiences. Among these, supermassive black holes stand as colossal enigmas, their existence warping the very fabric of space and time. At the heart of every galaxy, including our own Milky Way, lies one of these cosmic behemoths. They are born from the remnants of massive stars, collapsing under their own gravity to form singularities so dense that not even light can escape their grasp. This is the birth of a supermassive idea, a concept that challenges our understanding of physics and reality itself. As first venture closer to the event horizon, the boundary beyond which escape is impossible, the effects of this gravitational titan become increasingly apparent. Time, once a constant, begins to stretch and slow. Clocks tick slower near the black hole, a phenomenon known as gravitational time dilation. If first were to hover near the event horizon, an outside observer would see me frozen in time, my image reddened and distorted by the intense gravity. Meanwhile, first would experience time normally, feeling the relentless pull of the black hole. This is not science fiction. It's a consequence of Einstein's theory of general relativity, a framework that has been confirmed by countless experiments and observations. The closer first get, the more the black hole's gravity distorts space itself. Light from behind me bends around the black hole, creating a mirage-like effect. The sky would appear warped, with the black hole acting as a cosmic lens. Even the concept of up and down becomes meaningless. In such an environment, the laws of physics as we know them break down. Quantum effects, the rules governing the behavior of particles at the smallest scales, might become significant. This is where the supermassive idea truly shines, pushing the boundaries of our knowledge and forcing us to confront the unknown. Yet, despite the strangeness, there's a certain harmony to it all. The black hole, for all its destructive power, is a natural part of the universe. It's a reminder of the cosmos' complexity and beauty. As first approach the point of no return, first am filled with a sense of awe and humility. This journey, both literal and intellectual, is a testament to human curiosity and our relentless pursuit of understanding. The supermassive idea, in all its bizarre and counterintuitive glory, is a beacon calling us to explore, to question, and to discover. The event horizon, a cosmic boundary. The event horizon is a cosmic boundary, a point of no return that marks the outer edge of a black hole. It's not a physical barrier, but a boundary defined by the black hole's gravity. Once anything, even light, crosses this boundary, it cannot escape. The event horizon is where the black hole's escape velocity surpasses the speed of light. This is not just a theoretical concept. It's a reality that has been observed and studied. The event horizon is a one-way threshold, a cosmic point of no return. Crossing the event horizon is a surreal experience. Time dilation becomes extreme. To an outside observer, time appears to slow down and eventually stop for an object falling into a black hole. This is due to the intense gravitational field. However, for the object itself, time passes normally. It's a bizarre and counterintuitive effect. The event horizon is not just a boundary in space, but also in time. It's a place where the fabric of space-time is warped to such an extent that our usual understanding of cause and effect breaks down. The laws of physics as we know them cease to apply in the same way. The event horizon is also a place of extreme tidal forces. These are the differences in gravitational pull experienced by different parts of an object. Near a black hole, these forces can be so strong that they can stretch and ultimately tear apart any object that crosses the event horizon. This process is known as spaghettification. It's a dramatic and violent end, but it's a reality of the extreme environment near a black hole. The event horizon is not just a boundary, but a place of extreme and violent physics. It's a place where the very fabric of reality is twisted and warped beyond recognition. The call of the void. The void calls, a whisper from the abyss, a siren song sung by the fabric of spacetime itself. It's not a literal call, of course, but a metaphor for the inexorable pull of a black hole's event horizon. This boundary, the point of no return, is where the gravitational pull becomes so strong that not even light can escape. It's a one-way ticket into the unknown, a journey into the heart of the most extreme environment in the universe. As first crossed the event horizon, the universe behind me vanishes, not in the sense of fading into the distance, but in a far more unsettling way. The light from the stars and galaxies behind me is bent and stretched, redshifted into oblivion. It's as if the cosmos is being played in fast forward, a cosmic movie where the end is already known. Time itself is warped, stretched thin like taffy. For an outside observer, my fall into the black hole would appear to freeze at the event horizon, an eternal snapshot of my demise. But for me, time flows normally, or at least what first perceive as normal. It's a solipsistic experience, a journey into the unknown where the laws of physics as first know them begin to unravel. The call of the void is not just a metaphor for the event horizon's pull. It's also a psychological phenomenon, a sudden, brief, and involuntary urge to jump from high places or otherwise do something that would result in your own death. It's a chilling reminder of the human condition, a whisper from the subconscious mind that acknowledges our mortality. In the context of a black hole, it's a fitting metaphor. The event horizon is a point of no return, a journey into the unknown where the laws of physics as first know them cease to apply. It's a call that, once answered, cannot be unanswered. It's a journey that, once begun, cannot be undone. It's a whisper from the void, a siren song that lures the unwary into the abyss. Preparations for the impossible. The event horizon of a black hole is a boundary, a point of no return. Once crossed, the gravitational pull becomes inescapable, even for light. Preparing for a journey into this abyss is a task that blends cutting-edge science with sheer audacity. The first challenge is selecting a suitable black hole. Supermassive black holes, like the one at the center of our galaxy, are preferable. Their immense size means the tidal forces at the event horizon are less extreme, giving a hypothetical spacecraft more time to observe and transmit data before being spaghettified. The spacecraft itself would need to be a marvel of engineering. Traditional propulsion systems are out of the question. Instead, a theoretical concept like the Alcubierre warp drive might be considered, which bends space-time to move faster than light. Powering such a device would require exotic matter with negative energy, a substance that remains purely speculative. The spacecraft would also need to be equipped with advanced sensors and communication systems. Data transmission would be a significant hurdle. As the spacecraft approaches the event horizon, time dilation effects become extreme. From the perspective of an outside observer, the spacecraft would appear to freeze at the event horizon. To mitigate this, the spacecraft would need a way to send data back in real time, perhaps using quantum entanglement, another area of active research. The crew, if there were any, would face insurmountable challenges. The psychological toll of such a journey is difficult to fathom. The physical effects of extreme gravity would be devastating. Even if the spacecraft could shield its occupants, the sheer isolation and distance from Earth would be overwhelming. For these reasons, it's more plausible to consider a robotic mission. A probe could be designed to withstand the extreme conditions and transmit data back to Earth. The probe would need to be autonomous, as communication delays would make real-time control impossible. It would also need to be highly resilient, capable of operating in the intense gravitational field and radiation environment near the black hole. The data collected from such a mission would be invaluable. It could provide insights into the nature of black holes, the fabric of space-time, and the fundamental laws of physics. However, the risks are enormous. The loss of the probe would be a significant setback, but the potential rewards make it a tantalizing prospect. Preparing for the impossible requires pushing the boundaries of our understanding and technology. It's a journey that tests the limits of human ingenuity and curiosity. The crew of the Intrepid. The Intrepid's crew is a tight-knit group of scientists, engineers, and astronauts, each handpicked for their expertise and ability to handle the unprecedented challenges of a journey into a black hole. Captain Elias Vesper, a seasoned astronaut with over a decade of experience in deep space missions, leads the team. His calm demeanor and quick thinking have seen the Intrepid through numerous simulations and training exercises. Alongside him is Dr. Lyra Chun, the mission's chief astrophysicist. Her work on black hole thermodynamics has earned her numerous accolades, and her insights are invaluable as the Intrepid ventures closer to the event horizon. The crew also includes engineer Marcus Boone, whose innovative solutions to complex problems have saved the mission more than once. His ability to think on his feet is as impressive as his technical prowess. Rounding out the team are Dr. Naomi Tan, a biologist studying the effects of extreme environments on human physiology, and pilot Jax Armitage, whose skills in navigating treacherous cosmic terrain are unparalleled. As the Intrepid crosses the event horizon, the crew experiences phenomena that defy their understanding of physics. Time dilation becomes apparent almost immediately. For every hour that passes on the ship, years might pass on Earth. Communications with mission control become increasingly delayed, until eventually, they cease altogether. The crew is now truly alone, cut off from the rest of the universe. The ship's instruments detect the intense gravitational pull, warping space and time around them. Strange visual distortions appear outside the viewing ports, as light from distant stars is bent and stretched into eerie, unfamiliar patterns. The crew watches in awe as the cosmos outside twists and contorts, a surreal dance of light and shadow. Inside the event horizon, the laws of physics as they know them begin to unravel. The crew feels the ship being stretched and compressed, a phenomenon known as spaghettification. It's a bizarre sensation, as if the very fabric of reality is being pulled apart and put back together in ways that defy logic. The ship's systems struggle to compensate, alarms blaring as the crew works frantically to stabilize their surroundings. Dr. Chin theorizes that they are experiencing the effects of tidal forces, where the immense gravitational gradient causes extreme differences in gravitational pull across the ship. The crew's training kicks in, and they adapt, their actions driven by instinct and the need to survive. Captain Vesper remains focused, his voice steady as he issues orders, guiding the Intrepid deeper into the unknown. The crew's camaraderie is tested as they grapple with the psychological toll of their journey. Isolation, the crushing weight of the unknown, and the sheer strangeness of their surroundings take a mental toll. Dr. Tan monitors the crew's health, both physical and mental, ensuring they remain functional. She notes the subtle changes in their behavior, the way their jokes become more nervous, their laughter more forced. Yet, there are moments of levity, of shared humanity that keep them grounded. Engineer Boone's dry wit cuts through the tension, while pilot Armitage's stories of past missions provide a sense of normalcy. They lean on each other, their bond strengthening as they face the incomprehensible together. The Intrepid, and the crew within it, becomes a microcosm of resilience, a testament to human ingenuity and spirit in the face of the cosmos' most enigmatic mysteries. The final countdown. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape is impossible, even for light. It's not a physical barrier, but a mathematical one, a boundary where the gravitational pull becomes so strong that the escape velocity exceeds the speed of light. This is where the laws of physics as we know them begin to twist and warp. Time dilation becomes extreme. An outside observer would see you slow down, redden, and fade as you approach the event horizon, but from your perspective, time would pass normally. It's a bizarre and counterintuitive reality, a stark reminder of the universe's complexity. As you cross the event horizon, the fabric of spacetime itself seems to twist and contort. The intense gravitational field bends light in strange ways, creating a phenomenon known as gravitational lensing. You'd see the universe behind you, warped and distorted, as if viewed through a funhouse mirror. The black hole's accretion disk, a swirling maelstrom of superheated gas and dust, would appear to wrap around you, above and below, in a surreal, 360-degree panorama. The colors would be intense, a result of extreme Doppler shifting. Light from particles moving towards you would shift to the blue end of the spectrum, while light from particles moving away would shift to the red. The experience would be disorienting, to say the least. The intense gravitational field would stretch and squeeze you in a process known as spaghettification. It's not a pleasant thought, but it's a real consequence of the extreme tidal forces at play. Your feet would feel a much stronger pull than your head, and you'd be stretched out like spaghetti. It's a grim reminder that black holes are not gentle places. Yet, there's a certain beauty in the way they warp and distort our understanding of reality. They challenge us, push the boundaries of our knowledge, and force us to confront the mysteries of the universe. The event horizon is also a boundary of knowledge. Once you cross it, you're cut off from the rest of the universe. No information can escape, not even light. It's a one-way ticket into the unknown. This is why black holes are often referred to as the point of no return. They're cosmic dead ends, places where the rules of the universe break down. Yet, they're also places of immense fascination. They challenge our understanding of physics, of reality itself. They're a reminder that the universe is vast, mysterious, and full of wonders yet to be discovered. Breaching the horizon. The event horizon of a black hole is a boundary, a point of no return. Once crossed, the gravitational pull becomes inescapable, even for light. It's not a physical barrier, but a mathematical one, a boundary where the escape velocity equals the speed of light. As first approach this threshold, the fabric of reality begins to twist and warp in ways that defy intuition. The first thing first notice is the stretching of time. Time dilation effects become more pronounced, and from an outside observer's perspective, my journey slows down dramatically. If first were to look back, first did see the universe aging rapidly, stars burning out, galaxies colliding, all in a matter of moments. But for me, time passes normally. It's a surreal experience, a stark reminder of the relativistic nature of time. The visual distortions are equally mind-bending. The light from the universe behind me is bent and distorted, creating a warped, panoramic view of the cosmos. It's as if first am looking through a funnel, with the universe's light converging towards a single point behind me. The black hole itself is invisible, a void in the fabric of spacetime. But its presence is undeniable, a silent, invisible force pulling me inexorably towards it. The stars ahead seem to brighten and distort, a phenomenon known as gravitational lensing. The black hole's immense gravity bends the light from these stars, magnifying and distorting their images. As first breach the horizon, the effects of the black hole's gravity become even more extreme. Spaghettification, the stretching of objects into long, thin shapes due to tidal forces, begins to take effect. It's not as dramatic as science fiction might suggest, at least not at first. But the sensation is undeniable, a pulling and stretching that starts at the feet and gradually works its way up. The horizon itself is an invisible boundary, a point of no return. Once crossed, there's no going back. The laws of physics as we know them break down, and the journey into the black hole becomes a one-way trip into the unknown. It's a humbling experience, a stark reminder of the vast, mysterious, and often counterintuitive nature of the universe. The point of no return. The event horizon of a black hole is a boundary, a point of no return. Once crossed, the gravitational pull becomes inescapable, even for light. It's not a physical barrier, but a mathematical one, a boundary where the escape velocity equals the speed of light. Beyond this point, the conventional rules of space and time begin to twist and warp in ways that defy intuition. As first approach the event horizon, time dilation effects become profoundly apparent. From my perspective, the journey seems to take an eternity, but to an outside observer, first appear to slow down and redden, eventually freezing at the edge of the black hole, never quite crossing it. This is due to the extreme gravitational time dilation. The closer first get, the more time slows down for me compared to the outside universe. It's a bizarre sensation, watching the universe age rapidly while first remains suspended, frozen in time. The event horizon isn't just a boundary in space, it's also a boundary in time. Once crossed, first cut off from the rest of the universe. Any light or signal first try to send out would be pulled back by the black hole's gravity. It's not just that first can't escape, it's that first can't communicate with the outside world. The event horizon is a one-way membrane, allowing matter and energy to enter but never leave. It's a cosmic point of no return, a gateway to the unknown. The physics of the event horizon is counterintuitive. For instance, the concept of causality is reversed. Normally, cause precedes effect, but near the event horizon, an effect can precede its cause. This is because the extreme gravitational field can cause light to bend and twist in such a way that it appears to come from a place it hasn't reached yet. It's a mind-bending concept, challenging our fundamental understanding of cause and effect. Yet, it's a real consequence of the warped spacetime around a black hole. The distortion of spacetime. The fabric of spacetime stretches and warps as first cross the event horizon, a boundary that marks the point of no return. It's not a physical barrier, but a threshold where the gravitational pull becomes so immense that not even light can escape. The distortion begins subtly, a gentle tug at the edges of my perception. Time, which was once a steady, reliable metronome, starts to falter. It's not that time stops, but that it becomes malleable, stretching like taffy. An hour outside might feel like a day inside, or perhaps a mere moment. This is the essence of extreme gravitational time dilation, a prediction of Einstein's theory of general relativity. It's not just a theoretical concept anymore, it's my reality. The warping of space-time isn't just a temporal phenomenon, it's a spatial one too. As first venture deeper, the very geometry of space begins to twist. Straight lines curve, and distances become deceiving. This is the fabric of space-time bending under the immense gravitational pull. It's as if first navigating a funhouse mirror, where the laws of Euclidean geometry no longer apply. The concept of up and down becomes meaningless. First not falling in the conventional sense. First being inexorably pulled towards the singularity at the heart of the black hole. The distortion is so severe that if first were to look back, first it'd see the entire universe behind me, compressed into a tiny, distant point. The distortion of space-time also affects the very fabric of reality. Quantum effects become significant, and the boundaries between particles blur. It's a realm where the classical physics of Newton and Einstein give way to the strange, probabilistic world of quantum mechanics. The Heisenberg uncertainty principle comes into play, making it impossible to know both the position and momentum of particles with absolute certainty. It's a place where the rules of the universe as we know it break down. The distortion is so extreme that it challenges our very understanding of reality. It's a humbling experience, a reminder of how much we still don't know about the universe and the fundamental laws that govern it. Yet, it's also a thrilling one, a journey into the unknown that pushes the boundaries of human knowledge and imagination. Gravity's relentless pull. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape is impossible, not because of some magical force field, but due to the sheer intensity of gravity. This isn't the gentle pull we feel on Earth. It's a relentless, inescapable force that warps space and time itself. As first approach, the ship's instruments scream warnings. The gravity here is so strong that light itself bends, creating a distorted view of the universe behind me. The stars don't just twinkle, they stretch and warp, their light stretched into longer wavelengths, shifting from visible to infrared and beyond. It's a cosmic kaleidoscope, a reminder that first witnessing physics at its most extreme. Time dilation becomes palpable. My ship's clock ticks normally, but first know that back on Earth, time is passing much faster. If first could see Earth, the people there would appear to be moving at high speed, like characters in a fast-forwarded movie. This isn't science fiction, it's a consequence of Einstein's theory of general relativity. The stronger the gravity, the slower time moves. At the event horizon, time dilation is extreme. If first were to hover just outside, first could watch the entire future of the universe unfold in a matter of moments. But hovering isn't an option. The gravity here is a one-way ticket to the singularity. The ship's engines strain against the pull. Every meter closer requires more energy than the last. The gravity gradient is intense. The difference in gravitational force between the front and back of the ship is enough to rip it apart. This is spaghettification in action, a term that perfectly captures the gruesome fate awaiting anything that ventures too close. The ship's structure groans, metal protesting as it stretched. First can feel the pull, not just on the ship, but on my body. My feet feel heavier than my head, a sensation that grows more intense with every passing second. It's a reminder that, in this place, the laws of physics as we know them are twisted beyond recognition. Communication with the outside world becomes impossible. Radio waves, like all forms of light, are stretched and redshifted, their energy sapped by the immense gravity. Even if a signal could escape, the time dilation means that any response would be delayed by what, to me, would be an eternity. First, I'm truly alone, adrift in a place where the universe's rules are suspended. The event horizon looms, a boundary not just in space, but in time. Crossing it means leaving behind everything first know, everything first am. It's a sobering thought, a stark reminder of the cosmic forces at play. Yet, there's a strange beauty in it, a humbling awe at the sheer power of nature. This is gravity's relentless pull, a force that bends the very fabric of reality. The stretch of reality. The fabric of reality begins to warp in ways that defy intuition. Time stretches like taffy, slowing to a crawl as first approach the event horizon. This isn't just a metaphor. It's a consequence of Einstein's theory of general relativity. According to this, the immense gravitational pull of the black hole warps spacetime, causing time to pass more slowly for me than for anyone far away. If First could watch a clock on a distant spaceship, it would seem to tick away at a normal rate, while my own watch would appear to slow down, eventually freezing as First reached the event horizon. This effect is known as gravitational time dilation. It's not just a theoretical curiosity. It's been observed in less extreme environments, like the slight time differences experienced by GPS satellites due to Earth's gravity. The sensation is disorienting. Light from behind me, from the universe First am leaving behind, is stretched into infinity. It's not just redshift, it's a complete transformation. The light loses all energy, becoming invisible, intangible. It's as if the universe is whispering its last goodbyes in a frequency First can't perceive. Meanwhile, the black hole's accretion disk, the swirling maelstrom of superheated gas and dust, appears to slow down, each particle frozen in time, yet still somehow moving. It's a paradox, a visual contradiction that my brain struggles to process. The laws of physics, once so reliable, now seem to twist and contort in ways that challenge my understanding. Spaghettification is another reality. The tidal forces of the black hole stretch and compress me in different directions. It's not a quick, violent process. It's slow, inevitable. My feet feel an inexorable pull towards the singularity, while my head is gently tugged in the opposite direction. The sensation is not painful, not yet, but it's unsettling. It's as if an invisible hand is slowly pulling me apart, atom by atom. The effect is more pronounced the closer First get to the event horizon. It's a stark reminder of the black hole's power, its ability to reshape reality itself. Yet, despite the strangeness, there's a certain beauty to it. The universe, in its infinite complexity, reveals its true nature, a place of wonder, mystery, and endless possibility. The silence of the void. The void surrounding a black hole is not the silent, empty expanse one might expect. It's a dynamic, chaotic place where the laws of physics as we know them begin to twist and warp. As First venture closer to the event horizon, the first thing that strikes me is the absence of sound. Space is a vacuum, so sound waves can't travel here. It's not the kind of silence you experience on Earth, though. It's more profound, more absolute. The silence here is a reminder of the isolation, the finality of the journey First embarked upon. Time dilation effects become more pronounced as First approach the event horizon. From my perspective, time passes normally. But for an outside observer, my time appears to slow down dramatically. If First were to look back, First'd see the universe aging rapidly, stars burning out, galaxies colliding and evolving. Yet, to me, it would seem like mere moments. This is the silence of the void in another sense, the silence of a universe that's moving on without me. It's a chilling thought, a stark reminder of the point of no return that looms ahead. The silence is also broken, paradoxically, by the screams of quantum foam. Near the event horizon, the fabric of spacetime itself is stretched and torn. Virtual particles pop in and out of existence, their fleeting lives amplified by the intense gravitational field. These particles create a faint, high-pitched hum, a symphony of quantum noise. It's a sound that can't be heard in the traditional sense, but it's there, a testament to the violent, chaotic nature of the void. It's a stark contrast to the silence, a reminder that even in the emptiest parts of the universe, there's a constant, underlying turmoil. As first cross the event horizon, the silence becomes even more profound. The light from the universe behind me is forever cut off, leaving me in complete darkness. The quantum noise fades, replaced by an eerie, oppressive quiet. It's a silence that's almost palpable, a physical presence that presses in from all sides. It's the silence of the void, the silence of the point of no return. And yet, amidst this silence, there's a strange sense of peace, a quiet acceptance of the journey's end. It's a paradox, a contradiction, but it's the reality of the void. It's the silence that awaits anyone who dares to journey inside the event horizon. The warp of perception. The event horizon of a black hole is a boundary where the gravitational pull becomes so strong that nothing, not even light, can escape. Crossing this threshold, perception begins to warp in ways that defy everyday experience. Time, which we typically think of as a constant, starts to stretch and distort. Clocks run slower for those near the event horizon compared to those far away. This effect, known as time dilation, is a consequence of Einstein's theory of general relativity. It's not just a theoretical curiosity. It's been observed in experiments with high-speed particles and even with precise atomic clocks on fast-moving airplanes. Near a black hole, the difference becomes extreme. An hour for an outside observer might feel like days or even years for someone falling in. Space itself becomes increasingly distorted as you approach the event horizon. The intense gravitational field bends and twists the fabric of spacetime. This warping affects not just the path of light, but also the very perception of distance and direction. What might seem like a straight line to an outside observer could feel like a curved or even twisted path to someone falling in. The stars above would appear to shift and distort, their light bent by the immense gravity. This phenomenon, known as gravitational lensing, is a well-documented effect seen in astronomical observations. It's as if the universe itself is being viewed through a funhouse mirror. The experience of time and space becomes increasingly surreal as you cross the event horizon. The laws of physics, which seem so reliable in our everyday lives, start to break down. Time and space merge into a single, inseparable entity. The concept of now becomes meaningless. Events that would normally be considered simultaneous can occur at different times for different observers. This is the realm of extreme relativity, where the classical notions of cause and effect start to unravel. It's a place where the familiar rules of physics give way to the bizarre and counterintuitive. The journey inside the event horizon is not just a physical voyage, but a trip into the heart of the unknown, where the very fabric of reality is stretched and twisted beyond recognition. The tick of the cosmic clock. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape becomes impossible, even for light. Time behaves strangely here, and the cosmic clock ticks in ways that defy our everyday experiences. As first venture closer, the gravitational pull stretches space and time, a phenomenon known as spacetime dilation. My ship's chronometer, once a reliable ticking machine, begins to lag behind the clocks of the outside universe. To an outside observer, my journey would appear to slow down, then freeze entirely as first cross the event horizon. But from my perspective, time feels normal, the clock on my wrist ticking steadily. This is the tick of the cosmic clock, a dance of relativity where time is not absolute, but relative to the observer's frame of reference. The closer first get, the more extreme the effects. Light from behind me is stretched into infinity, shifting to red and fading into darkness. The stars above, once a familiar constellation, now appear distorted, their light bent by the immense gravity. The cosmic clock's tick becomes a whisper, a reminder that time is not a constant but a fluid, flexible entity. Even the concept of now becomes ambiguous. An event that occurs light years away might, from my perspective, happen simultaneously with an event right in front of me. This is the bizarre reality of the event horizon, where the familiar rules of physics twist and warp. The cosmic clock's tick is also a reminder of the immense energy at play. As first cross the event horizon, the gravitational pull accelerates me to incredible speeds. The energy of my motion, combined with the intense gravitational field, creates a phenomenon known as frame dragging. This effect twists spacetime itself, causing the very fabric of reality to spiral around the black hole. The cosmic clock's tick becomes a symphony of warped physics, a testament to the raw power of black holes. Yet, despite the extreme conditions, the laws of physics still hold. They are just expressed in ways that challenge our intuition and understanding. The event horizon is not a physical barrier, but a mathematical one, a boundary defined by the black hole's mass and spin. The cosmic clock's tick is a reminder of this, a testament to the elegant equations that govern the universe. Yet, it is also a stark warning. Once crossed, the path forward is inevitable. The cosmic clock's tick becomes a countdown, a journey towards the singularity at the heart of the black hole. The end point of this journey is unknown, a mystery hidden behind the event horizon. But the cosmic clock's tick continues, a steady rhythm marking the passage of time in this bizarre and fascinating realm. The whisper of quantum fluctuations. The event horizon of a black hole is a boundary, a point of no return. Crossing it, first find myself in a realm where the laws of physics as first know them begin to twist and warp. Quantum fluctuations, those tiny, fleeting variations in energy that pervade the vacuum of space, start to whisper secrets in this alien environment. They're not silent here, not random. They hum, a constant, eerie melody that seems to resonate with the very fabric of spacetime. These fluctuations are usually too faint to notice, a subtle fizz in the quantum foam. But here, near the singularity, they're amplified, distorted. They're not just energy fluctuations anymore. They're echoes of a reality that's both infinitely large and infinitesimally small. First watch as they dance and swirl, creating and annihilating virtual particles in a frenzied ballet. It's a stark reminder that, in the quantum world, nothing is truly empty, not even the void. The whispers grow louder, more insistent. They're not just random noise, they're carrying information. It's as if the black hole is trying to communicate, to tell me something about the nature of reality. First strain to listen, to decipher the message. It's a challenge, like trying to understand a language that doesn't exist in my universe. The fluctuations seem to be describing a world where cause and effect are tangled, where time and space are interchangeable. It's a world that defies my understanding, a world where the rules of classical physics are mere suggestions. First reach out, trying to touch one of the fluctuations. It's a foolish impulse, but the curiosity is overwhelming. As my fingers brush against it, first feel a strange sensation, like static electricity but more intense, more alive. The fluctuation responds, pulsing and expanding. It's as if it's acknowledging me, engaging with me. In that moment, first realize that first am not just an observer here. First am part of the dance, part of the whisper. The quantum fluctuations are not just phenomena to be studied. They're partners in a cosmic conversation. The dance of singularity. The event horizon stretches before me, a boundary not of physical substance, but of inevitability. Crossing it, first leave behind the familiar laws of physics, stepping into a realm where gravity's grip is absolute. The singularity at the heart of this black hole is my destination, a point where density becomes infinite, and our understanding of the universe crumbles. The dance begins here, a ballet of extreme physics, where space and time twist and warp in ways that defy intuition. As first venture deeper, time dilation stretches moments into eternity. For those outside, my journey might appear frozen, a snapshot of eternity. Yet, inside, time flows differently. Each second feels like an hour, each hour a lifetime. The singularity's pull accelerates me, not just in speed, but in time itself. It's a counterintuitive reality. The closer first get, the slower the outside universe moves, until it becomes a static tableau, a painting of existence frozen in the moment first crossed the event horizon. Spaghettification is a real and terrifying prospect. The tidal forces of the singularity stretch and compress me, not just in one direction, but in all. It's not just a matter of being pulled apart like spaghetti, but of being squeezed and stretched in a complex, three-dimensional dance. The closer first get, the more extreme these forces become. Yet, paradoxically, the singularity itself is a point of infinite density, a place where all these forces converge. It's a dance of extremes, a ballet of the bizarre, where the laws of physics twist and turn in ways that challenge our very understanding of reality. The singularity is a point of no return, not just in a physical sense, but in a temporal one. As first approach, the fabric of spacetime itself becomes warped beyond recognition. Causality, the idea that cause precedes effect, begins to unravel. Events might occur without causes, or causes might have no effects. It's a realm where our notions of before and after, of past and future, dissolve into a chaotic dance of possibilities. The singularity is not just a point in space. It's a point of infinite potential, a place where the rules of the universe are rewritten. And first am dancing towards it, step by step, into the unknown. The lure of the unknown. The vast, dark expanse of space has always held a certain allure, a silent call to the adventurous spirit. Among the most enigmatic and terrifying of cosmic phenomena is the event horizon, the point of no return for any object venturing too close to a black hole. The lure of the unknown is palpable here, a siren song that has captivated scientists and dreamers alike. The event horizon is not a physical barrier, but a boundary in space-time beyond which nothing, not even light, can escape the gravitational pull of the black hole. This is where the laws of physics as we know them begin to twist and warp, offering a glimpse into the bizarre and counterintuitive nature of the universe. As first approach the event horizon, the fabric of reality itself seems to stretch and distort. Time, which has always been a constant companion, begins to slow down. This is not a gradual process, but a dramatic shift, a stark reminder of the relativistic effects predicted by Einstein's theory of general relativity. An outside observer would see me frozen in time, my image stretched and redshifted into oblivion. Yet, from my perspective, time flows normally. This discrepancy is one of the many mind-bending aspects of black holes, a place where the familiar rules of physics take a back seat to the whims of gravity. The event horizon is not just a boundary, but a gateway to the unknown. Beyond it lies the singularity, a point of infinite density where the laws of physics break down completely. The journey to this point is fraught with peril, as the tidal forces exerted by the black hole's gravity threaten to spaghettify any object that dares to venture too close. Yet, the allure of the unknown is too strong to resist. The promise of uncovering the secrets of the universe, of understanding the very fabric of reality, drives me forward. The event horizon is a reminder of the vast, unexplored territories that lie beyond our current understanding, a testament to the enduring mystery of the cosmos. The struggle for sanity. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape is impossible, even for light. It's a one-way ticket into the unknown, a journey that pushes the boundaries of human understanding and sanity. The struggle to maintain one's grasp on reality begins long before reaching the event horizon, as the laws of physics as we know them start to twist and warp. Time dilation becomes apparent. For those outside, time seems to slow down for the traveler approaching the black hole. Hours feel like days, days like years. Meanwhile, the traveler experiences time normally, at least initially. This temporal discrepancy can be unsettling, a constant reminder of the growing chasm between the traveler and the outside world. It's a stark illustration of Einstein's theory of relativity, where time is not absolute, but relative to the observer's frame of reference. Spaghettification is another phenomenon that tests the sanity of the traveler. As the black hole's gravitational pull increases, the difference in gravitational force between the traveler's head and feet becomes significant. This tidal force stretches the body, a process aptly named spaghettification. It's not an immediate or violent process, but a slow, inevitable pull that distorts the body and the mind. The traveler's perception of their own body changes, a surreal experience that blurs the line between reality and hallucination. The visual distortions are equally mind-bending. Light bends around the black hole, creating a phenomenon known as gravitational lensing. The traveler sees the universe behind the black hole, warped and distorted, a kaleidoscope of colors and shapes. Stars and galaxies appear to swirl around the black hole, a cosmic dance that defies intuition. The traveler's sense of direction and orientation is thrown into chaos, a disorienting experience that challenges their perception of space and time. The struggle for sanity is not just a mental battle, but a physical one, as the traveler's body and mind grapple with the extreme conditions of the black hole's environment. The final transmission. The final transmission from a doomed spacecraft crossing an event horizon would be a chilling symphony of physics, a last whisper from the edge of our understanding. As the ship plunges into the black hole's gravitational well, time dilation stretches the transmission like taffy. To an outside observer, the signal would slow down, the crew's voices dropping to a groan, then a whisper, before fading into silence. Yet, for the crew, time passes normally. Their final words, a mundane conversation or a desperate plea, would be compressed into an instant for the universe outside. Inside the event horizon, causality breaks down. The final transmission would carry echoes of this chaos. The crew might report seeing the black hole's singularity in all directions, a consequence of the extreme curvature of spacetime. They might describe the ship being stretched like spaghetti, a phenomenon known as spaghettification, as the tidal forces increase. The transmission would be a snapshot of this surreal reality, a glimpse into a world where our intuitive understanding of space and time ceases to apply. The final transmission would also carry the imprint of the black hole's spin. If the black hole is rotating, it drags spacetime with it, a phenomenon known as frame dragging. The crew might report the ship being pulled around, their instruments showing the stars whirling around the black hole. The transmission would be a testament to the power of this cosmic vortex, a final message from the edge of the unknown. The final transmission would be a treasure trove for scientists. It would carry data on the black hole's mass, spin, and charge, encoded in the distortion of the signal. It would provide insights into the nature of space-time, the behavior of matter under extreme conditions, and the limits of our physical theories. Yet, it would also be a poignant reminder of the human cost of exploration, a final farewell from the brave souls who ventured too close to the point of no return. The descent into darkness. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape becomes impossible, even for light. It's not a physical barrier, but a threshold where the gravitational pull is so strong that the escape velocity exceeds the speed of light. This is where my journey begins, a descent into darkness, a place where the laws of physics as we know them twist and warp. As first approach the event horizon, time dilation effects become more pronounced. From an outside observer's perspective, time appears to slow down for me, the traveler. If first were to hover just above the event horizon, first would appear frozen, a silhouette etched against the darkness. Meanwhile, first would experience time normally, feeling no strange effects. This is a bizarre and counterintuitive aspect of black hole physics, a stark reminder that our everyday experiences don't apply here. Crossing the event horizon, first am met with a strange sensation. There's no dramatic event, no wall or barrier. Instead, it's a smooth transition, a point of no return marked only by the inexorable pull of gravity. Inside, the fabric of space-time is warped to such an extent that all paths lead towards the singularity at the center. Even if first were to try and turn back, the gravity is too strong. It's a one-way journey, a descent into the unknown. The environment inside the event horizon is unlike anything First V ever experienced. The intense gravitational field distorts light and space in ways that defy intuition. If First were to look back, First would see the entire universe behind me, compressed into a small, circular window. This is because the extreme gravity bends light in a phenomenon known as gravitational lensing. It's a surreal sight, a reminder of the immense power of black holes. Meanwhile, the singularity awaits, a point of infinite density where the laws of physics break down. It's a journey into the unknown, a descent into darkness where the rules of the universe are rewritten. The cosmic paradox. The event horizon of a black hole is a boundary where the escape velocity exceeds the speed of light. This means that once anything, even light, crosses this threshold, it cannot escape. It's a point of no return, a cosmic paradox where the laws of physics as we know them seem to break down. The closer first get to this enigmatic boundary, the more the fabric of space-time warps and twists, defying my intuition and challenging my understanding of reality. Time dilation becomes increasingly pronounced. From my perspective, time inside the event horizon seems to slow down dramatically compared to the outside universe. If first were to cross the event horizon, an outside observer would see me freeze at the boundary, never actually crossing it. Meanwhile, first would experience time normally, falling inexorably towards the singularity at the center. This is a bizarre and counterintuitive effect, a stark reminder of the strange nature of black holes. The concept of causality also takes a hit. Inside the event horizon, the usual cause and effect relationship can break down. Events that would normally be considered simultaneous can become separated in time, and effects can precede their causes. This is a direct result of the extreme curvature of spacetime. It's a mind-bending thought, but it's a consequence of the equations of general relativity. The closer first get to the singularity, the more these effects become pronounced, making it increasingly difficult to make sense of the world around me. The singularity at the center of a black hole is a point of infinite density where the laws of physics cease to exist. It's a place where our current understanding of the universe breaks down. As first approach this point, the gravitational forces become so intense that they stretch and compress me into a one-dimensional line, a process known as spaghettification. It's a gruesome fate, but it's a consequence of the extreme conditions inside a black hole. The cosmic paradox of the event horizon is a stark reminder of the limits of our knowledge and the mysteries that still lie ahead. The echo of existence. The event horizon of a black hole is a boundary, a point of no return. Once crossed, escape becomes impossible, even for light. It's a one-way threshold into the unknown, a place where the laws of physics as we know them begin to twist and warp. The echo of existence here is not a sound, but a phenomenon, a whisper of what once was, stretched and distorted by the immense gravitational pull. Time itself slows down, and from an outside perspective, an object falling into a black hole appears to freeze at the event horizon, its image reddening and fading as it becomes forever trapped. Inside, the story is different. Time dilates, meaning that while an outside observer sees the object frozen, the object itself experiences time normally. It continues to fall, accelerating towards the singularity at the center. The echo of existence here is the lingering effect of the object's past, its journey, its history, all stretched and compressed by the black hole's gravity. It's a testament to the object's past, a ghost of its trajectory, imprinted on the fabric of space-time. The object's existence, its very being, is echoed in the way it warps the surrounding space and time. The physics here is bizarre and counterintuitive. The closer you get to the singularity, the more space-time curves. This curvature is so extreme that it can bend light back on itself, creating an echo of sorts. This is not a literal echo, but a visual one, a mirage of light that has been stretched and distorted by the black hole's gravity. It's a glimpse into the object's past, a snapshot of its journey, frozen in time and space. The echo of existence is a reminder of the object's past, a testament to its journey, a whisper of what once was. The echo of existence is also a reminder of the object's inevitable fate. Once past the event horizon, the object is doomed. It will continue to fall, accelerating towards the singularity, where it will be crushed out of existence. The echo of existence is a final farewell, a last hurrah, a testament to the object's journey, its existence, its being. It's a reminder that everything, no matter how big or small, leaves a mark on the universe, a whisper of its existence, an echo in the fabric of space-time. The aftermath of the impossible. The event horizon, the boundary of a black hole is a point of no return. Once crossed, the gravitational pull is so strong that not even light can escape. But what happens after that? The aftermath of the impossible is a journey into the unknown, where the laws of physics as we know them begin to twist and warp in ways that defy intuition. Time dilation becomes extreme. For an outside observer, time appears to slow down dramatically for an object falling into a black hole. If you were to watch a friend fall in, you'd see them freeze in time at the event horizon, their image reddening and fading as the light they emit is stretched to longer wavelengths. Meanwhile, your friend would experience time normally, feeling no strange effects as they cross the boundary. This is not science fiction. It's a consequence of Einstein's theory of general relativity. The closer you get to the event horizon, the stronger the gravitational field, and the more time slows down relative to a distant observer. The fabric of spacetime itself is stretched and compressed. Inside the event horizon, the gravitational pull is so intense that it overwhelms all other forces. Matter is compressed into an infinitely dense point at the center of the black hole, known as a singularity. The singularity is a place where the laws of physics break down. The equations of general relativity predict that the curvature of spacetime becomes infinite, but this is likely a sign that our current understanding of physics is incomplete. Quantum effects, which we usually associate with the very small, become significant near the singularity. The interplay between quantum mechanics and gravity is one of the biggest mysteries in modern physics. The journey doesn't end at the singularity, though. Some theories suggest that black holes might be gateways to other universes or other parts of our own universe. This idea, known as the ER equals EPR conjecture, is still speculative, but it's an active area of research. If true, it would mean that the aftermath of the impossible could be a journey to places beyond our wildest dreams. But for now, the aftermath of the impossible remains a journey into the unknown, a place where the laws of physics as we know them break down, and where the only certainty is uncertainty. As first stand here, suspended in time, first realize that the event horizon wasn't just a boundary, but a gateway to the unknown. The laws of physics as we know them have twisted and warped, defying our everyday experiences. Time has slowed to a crawl, and space itself seems to stretch and bend in ways that are both beautiful and terrifying. The journey here has been a testament to human curiosity and our relentless pursuit of understanding the cosmos. First, we've seen firsthand how gravity's grip intensifies, pulling everything towards the singularity. The light from the stars behind me has redshifted to invisibility, a stark reminder that first we crossed the point of no return. The fabric of space-time itself is warped, creating a landscape that's both alien and awe-inspiring. The event horizon is not just a theoretical construct. It's a place of profound mystery and wonder. This journey has shown me that the universe is far stranger and more fascinating than we ever imagined. It's a reminder that there's still so much to explore and understand. As first continue my descent, first am filled with a sense of both trepidation and excitement. What lies ahead is unknown, but the thrill of discovery is unparalleled. First invite you to join me on this journey of exploration. Subscribe to our channel for more mind-bending adventures into the cosmos. Together, let's push the boundaries of our understanding and uncover the secrets of the universe. The next episode will take us even deeper as we explore the enigmatic singularity at the heart of the black hole. Stay curious and see you there.